QR code is not working.
I just used that one with you.
Already? So do I have that? Oh, yeah, I should sign in. It's not good.
Of course, it's not working for me, so. Is there an on-off button in this thing? Oh, it's off. Let's try it on. So we will go ahead and get started, if you don't mind. So this is the Jose Working Group at IETF 119. Welcome, everyone. As you know, and these are your chairs, all three of us, John and me. Is it not on? It feels loud to me.
You just need to be a little bit speak.
Can you hear me?
A little bit closer, I think.
How about this? Okay, excellent. Welcome to the IETF Jose Working Group. And with that, this is the note.
We should remind people to code in. Apparently the QR code outside wasn't working, but that one is.
Okay. So there are reports that the outside QR code is not working, so be sure to use the one on the screen in front of you or just log in through Data Tracker. Works as well. With that, this is the note well for the IETF. You will have agreed to this when you registered for this meeting. Any contributions and any discussions in these meetings all fall under the purview of our note well. Along with that, there's also all of our process and code of conduct, anti-harassment, those kinds of things. If you have any questions about any of these, please be sure to ask either one of your chairs or our area director, who was Roman, and I'm not sure if it's going to transition to Deb or are we transitioning to Deb or to Paul? Okay, well, we will have a new AD at the end of this week. I'm just not sure who is it? Okay, we'll find out. We don't know. But anyway, as you all are probably aware, Roman is now the general chair, and we will get a new security area director responsible for our work. So I would talk to them. This few things, the draft minutes will be taken on the online notes tool. Please help contribute. I did send an email suggesting that we could use any volunteers for minutes. I'm not sure if somebody has responded to that email. Is anybody willing to help with minutes? Minutes? Thank you, Ori. I love volunteers. Also, remember a reminder to use the Q tool, which again will be why you will need the QR code or to log in. Be clear, concise, and respectful, and act according to our code of conduct. Brian, did you want to say something? No, he just hit the wrong button. Okay, this is our agenda. We have a fairly full agenda for today. Is there any agenda bashing? Nope. Okay, with that, the web proof drafts, Mike, you're presenting, right? Web proof specifications. Confirm your.
And you can advance slides for me, or does that work?
It works if you.
Good afternoon. I'm Mike Jones. Thank you for coming. And we'll talk today first about the JSON Web Proofs work, which we got in some sense, this working group was rechartered in order to do this and related work. So there's actually been a lot of progress since we last met our heroes in Prague. There have been substantial normative and editorial updates to all three of the related specifications. Among other things, there were a bunch of places that the spec used to just kind of define things by examples, and now I tried to do a comprehensive pass to have normative statements about what those things that are also still in the examples do, where we define header parameters and algorithms and the such. Now there's requested IANA registrations for them. The proof representations were updated to be able to contain multiple parts, which simplifies some things for some of the algorithms. It turns out that there's an ambiguity, or there was an ambiguity about you couldn't tell the difference between an undisclosed value and a zero length value to be disclosed. And we fixed that. We defined some terminology and put them in terminology sections. There's some moving parts that were dependent upon, including the BBS signatures draft and the BLS key representations draft, and both the references and the examples were updated to use the current versions of those. And there's more and better examples. I did a full proofreading of the thing in December and filed a bunch of editorial and normative stuff as a result of that. And we've finally made our way through the majority of the issues and PRs that previously had been hanging around. So I'm happy with the amount of progress on the drafts. There is a landscape of related specifications, two of which I referenced earlier. The BBS signatures draft continues to evolve. It turns out that the signature format hasn't changed, but the proof format has changed a couple of times based on input from real cryptographers. And it turns out that that may not be done. But our drafts use some open source software that does generate or does perform the BBS computations in alignment with the current BBS drafts. Then, I read the key representations draft for COSE and discovered that it was inconsistently using the key type parameter. So I fixed that, and just mostly editorially, the letters BLS are people's initials, just like RSA are people's initials. So we determined, oh, those should all be spelled in uppercase. These are the decisions that really matter. Finally, come to COSE tomorrow, because Tobias Looker is going to be talking about whether to add a compressed key representation or not. Currently, we just have uncompressed. Turns out that there's a bespoke key representation in an underlying draft that's is it crypto cache or something defined. Anyway, this is not for us, but just saying we have some dependencies on things that are still moving parts. So what do we think we should be doing next? We should continue working through issues. You can file issues. This is where to do it. It's in the slides, and you can get the slides online. Continue tracking changes to the specs we're dependent upon. We would really like to add representations for another zero knowledge proof algorithm other than BBS. That said, in an ideal world, we would like that algorithm to be standards track and have multiple interoperating implementations. Some people have talked to us about ZK snarks. There's been some other possibilities. None of those meet all the criteria, but we have a working group. To the extent that any of you is interested in defining representations for an additional ZKP algorithm, the editors feel like that would give us more confidence that the container format that we're defining is actually general purpose and not overly specific to the things that we already know and understand. So if any of you love a ZKP algorithm, come talk to me, put it on the list and whatnot. Finally, there are several implementations out there. Some of the implementers have been filing issues, which is great. And I think we're coming up on the time that we would learn things from trying to get the different implementations to interoperate and see what works and what breaks and what was commonly understood and what was misunderstood and what we didn't write right. So it's your turn to tell us now what you think about where we are and where we want to go. The floor is yours.
Go ahead, Ori.
Hi, Ori Steele. On the comment about additional algorithms, just for folks who are maybe considering hunting for an algorithm that might fit well with JSON web proofs, I would personally really love to see something lattice-based or error coding based, something that can something that's not based on the elliptic curve discrete log in terms of the cryptographic problem the signatures and proofs are based on, just because of all of the debate within CFRG and other organizations on post-quantum threat model and migration strategies. So if it were possible to find something that fit that category of we think this is maybe going to do well, when compared against the discrete log, that would be really awesome. I'm not a cryptographer, but I would love it if someone who's excited about lattices and has something that they're aware of that might fit these interfaces could share. That would be great.
Yeah, agreed. And I'll just repeat, it's really going to take a volunteer who's passionate about this to write some text and work with the working group to add this. Procedurally, everything we're doing now is standards track. And so when we decide we're done, we could take these to, the various last calls and the RFC editor. The lattice stuff, if it's not, or, ZK snarks or whatnot, if there's not CFRG RFCs on the way, we could still define this stuff. We might put it in another draft so that it can progress at its own natural rate and not delay completion of this work.
Comment on algorithms. Both the COSI and the HOSE charter says that should have IETF consensus algorithms, for example, CFRG or NIST standards shall not invent new algorithms, but these are not new either. But I think any gray zone algorithm should be aligned with the AD, so we don't end up in a situation like this LVIG elliptic curve draft that got stopped in ISG. I think sync with the AD what the AD want.
Absolutely.
David? David, do you still want to be in the queue? Let me go to Michael and we'll come back to David.
Hey, Hey, Mike Perrock here. Yeah, thanks for this. And just to follow on with Ori, I know Plaza would be the one thing I would be tracking from a ZKP standpoint as far as lattices go. I don't think that work's going to resolve till like 2026, but there's some good starting places on that. So now might be a good time to get some of that in front of CFRG. I know some of those prior things that this is built on have been reviewed there. So I did put a link in the chat to one of the more current papers on that. So definitely worth reviewing there. So.
Sure, if that could get its way into the notes, that would be really helpful.
Okay, so David seems offline. There's no more questions on this draft. All right, we'll move to the next one.
And what do you know? I'm still here. This time to talk about work I've been doing with the working group and Ori Steele as a co-editor on fully specified algorithms for Jose and Jose. Next. Oh, wait, I can do next. I am empowered. So the last two IETFs, I've talked about why do this and what it would be. I am not going to do that here. There's links in the deck, both to the introduction to the draft that says why do this and what we're doing. And you could look at the slides from last time if you are unfamiliar with why we're motivated to do this work. So there's been progress since IETF 118. At 118, this was an individual draft. There was support in the working group meeting to adopt it. And then we held a successful call for adoption in January. That there was a lot of feedback. A lot of people said yes. A few people also said, I wouldn't do this, I would do it differently, or if you're going to do it, these are the things I would try to cover. And, you know, I value that feedback as much as the people who said, yeah, do this, because there's useful information that we've mined and tried to use to improve the specification since that. So we published a 0.0 draft that was just the individual draft turned into a working group draft in January. And then we've published two subsequent drafts that are intended to incorporate some of the working group feedback we received during the adoption call. There was text added on what it means to be fully specified when you're using multiple algorithms in a computation. Well, when would you do that? JSON Web Encryption has both an algorithm, an alg parameter to establish the key, and an ENC algorithm to do the block encryption. And we talk about both of those needing to be fully specified, even if independently, for the combination to be fully specified. Likewise, Jose, there's multiple algorithms in different phases of the computation. In particular for Jose Encrypt, you get the same thing. You have an algorithm to establish the key, and you have an algorithm to do the bulk encryption. Ori's been tracking some of the post-quantum work, which you'll hear about in Jose tomorrow, but we added text on key establishment methods, what it means for them to be fully specified and encapsulated keys. And we tweaked the instructions to the designated experts to make them even more precise. There's one set of open questions which was raised in the last IETF and has been discussed on lists since that, which is what to do about elliptic curve Diffie-Hellman key agreement and its friends. ECDH takes as a parameter an ephemeral key, which has a key type and an algorithm. which means that ECDH as it's written down is not fully specified. And there's been disagreement among well-intended parties about whether this draft needs to deal with that right now before we proceed, or whether we can define the principles, do the new algorithms for the low-hanging fruit, and leave it up to the working group to decide whether to do another draft that creates replacements that are fully specified for some of these things, and ECDH being the primary example. So there's a question, and I'm open to either answer from the working group, as I believe is Ori. Should we create fully specified algorithm identifiers for ECDH? So for instance, you might have ECDH ES using ES256. You might have ECDH ES256 for A128 key rep and equivalent things in the Cosé space. Some have said on list that we think if we're going to do any of this, this draft should do the whole job. Others have said it's okay to do the low-hanging fruit, which we feel like we've done, and decide later to do more or not. Brian Campbell and Alari very usefully did at least, a back of the envelope of how many new algorithms would we be defining if we define fully specified variants of elliptic curve or of Diffie-Hellman key agreement, and it would be 10 or 12 or something. So let me pause to have us discuss this point in the room.
Go ahead.
Mike Prorock. Yeah, I do think we should fully specify them because otherwise people will get themselves inevitably in trouble. And that's part of the reason we want to fully specify this stuff to begin with. I actually am a fan due to the unique characteristics of Diffie-Hellman stuff to put that in its own draft because that can give some introductory text as to why, given kind of the ephemeral key parameter nature of things, that you would want to handle this as its own kind of thing and then list those things out cleanly in one place. So I think doing that as a separate draft versus the low-hanging fruit that's already been done is totally fine.
Thank you.
Philip?
Thank you. Hi, and good morning, everyone. Question to Brian, I guess I see him in the audience there. The 10 to 12 new algorithms, was that a product of the Cartesian matrix, or was that something that had to do with the relative strength of the ECDH and then the curve, and then possibly in the key rep portion also the key rep?
Hi, Philip. It was taking the Cartesian product and trying to whittle it down to those that made sense based on the related strengths of the composite algorithms. I don't remember exactly what it was, but I think the email listed them. That was the idea anyway, but it was kind of back of the envelope thinking.
Right. The thing that I worry is that like the Cartesian itself would be, as far as I can say, there's 4 ECDH algorithms today. There are 5 curves registered for ECDH if I omit the SEC-P256K one, which is not defined for ECDH. So that gives me 20 already. So that's why I was asking. 20 would be an overkill, I guess. So if we are only considering the ones that make sense, and I can see that in the slides now. I'm sorry, it's 6:30 in the morning for me. So I never quite left Prague after the last IETF. So thank you, Brian.
Brian, did you want to?
I was still on the queue, so
Yeah,
if you
you're
don't
on the
mind.
queue.
So part of the thinking in that was trying to enumerate the number of new algorithms that would be there and get it down to something that made sense. But as I said at the end of that email, even 10 or 12 feels like a lot. And given the current state of, I don't know, support for this stuff, libraries out in the world, that the polymorphic nature of these algorithms has not manifested itself as a problem in implementations and deployments, at least to the extent that I'm aware of. I am really reluctant to work to make these fully specified, sort of just for the sake of making them fully specified. It feels like maybe a lot of work and ecosystem interoperability pain without any real benefit. It feels odd to talk to Mike on the phone. But I'm not sure there's really value in doing it. I'd be really reticent to take that on, particularly as a maintainer of a library. Like, it would be a bunch of work and support work that almost feels like make work for a upside benefit that's not at all clear.
Okay. Chris? We can't hear you, Chris. Did you want to try again? And you're gone. Ori, do you want to go ahead and go to the mic? And we'll come back to Chris. in just
All
a
right,
second.
Ori Steele. So I just wanted to say, like, with HPKE, the HPKE chems are fully specified. And so I kind of agree with what Brian had said, and I think others have said this on the list. Like, to fully specify these algorithms, it doesn't, to me, seem like it's providing tremendous value. And in particular, if we look at like where HPKE is fitting into HOSI and COSI today, a lot of the HPKE algorithms, they're fully specified, and they're kind of the thing that I would be moving to if I was doing one of these today. And so if you're going to end up implementing HPKE in the future, I think you'd probably be sad as an implementer to do that and then also do this. So just some, the comment there is like HPKE, and its chems and fully specified chems are going to be maybe the better place to see this kind of fully specified algorithm be applied in HOSI and COSI. And so I would tend to say either do it in a separate document or don't do it at all and just use HPKE. That's it.
Okay. Any other comments for the queue? I assume you'll do this, but there's a couple of notes in the chat for you. All right.
Let's see. Okay. So I suspect we should call this question on the list as well. I guess I'm willing to do the work to at least write down for people to review what it would look like to do this. Per Ori and Mike Prorock's suggestions, maybe put it in a separate individual draft right now. And then, the working group could by acclamation say, no, put it in the main draft, or no, don't. But that's what I hear and what I think might help us make a decision.
Yeah, Mike Perrock again. I'll add a quick follow on, Mike, because I've seen comments both on the list as well as at some of the prior meetings, and then just again in the chat here on some folks who have said, yeah, I got myself into trouble by doing this. Oh, sorry. Yeah, I think Ori made a really good comment about HPKE, et cetera, kind of being the path forward here, right? So by separating this out, if someone needs to go pick this up because they got themselves in trouble, cool, we've given a mechanism to do that. But we haven't bound ourselves to necessarily go commit to all that work unless we know for sure that it's actually worth doing, right?
Yep. So finally, I will ask this question on list probably after writing down what I think the new algorithms would be, which may not be a draft, it might just be an email message at first. But I think that's the only open question left for the draft. And so after we have a reasonable discussion of that, it seems to me that we could just do a working group last call once that question is decided. That's obviously up to the esteemed chairs to my left and our new area director, whoever that shall be.
It is Deb.
Okay. Good. With that, I believe I am done. Thank you.
Okay. Okay, up next, use of HPKE for Jose. There we go.
Good afternoon, everyone. I'm Thiru. We presented this draft in the last working group, and after that we had several comments. So we've been working on fixing these comments, and I would like to give an update on what changed from the time we presented it and till now. A quick overview is that we have two new modes defined. One is the HPKey direct encryption mode, which is more or less similar to the direct encryption mode. In addition to it encrypts the payload as well. And the other HPKey key encryption mode, which encrypts the content encryption key, especially for multiple recipients. Why HPKey? HPKey specification has been defined a few years back for basically public key encryption of arbitrary size plain text for a recipient public key. HPKey is used by several IETF specifications, obvious HTTP, encrypted client hello, and in MLS as well. We have a similar draft running in COSE working group as well. And the best part is HPKey interfaces are friendly to hybrid encryption, and we have published a draft discussing how it can be extended to hybrid encryption, where we can use both the PQC and traditional algorithms. Yeah, so we decided to pick the fully specified algorithm instead of the a la carte approach, which is very similar to what COSE draft does. So that's basically the HPKey. The mode is basic, or it's going to be authentication or authentication with asymmetric keys, or it can be authentication with asymmetric keys and PSK, or just the PSK mode. And then the key derivation function for deriving the keys, and then the AID algorithm for encrypting the payload or the content encryption key. We are pretty much leveraging all these values from HPKey INR registry, so we're not inventing anything new there. So after all the discussion, it's eventually boils down to two modes that we have defined, one for single recipient and one for multiple recipients. It works in both the serializations, and in the first case, the key that is derived from HPKey is used for encrypting the payload, and the other case for encrypting the content encryption key. Yeah, so we are leveraging the APIs that are exposed by HPKey specification and available in most of the predominant implementations today, which is to use the setup base function to create the HPKey context. And in case of the direct encryption mode, the plain text will be passed to the seal function, which will get the content encrypted. In case of key encryption mode, the plain text will be passed into the seal function, which will encrypt the content encryption key. And the receiver will basically use setup based receiver, where it uses the ephemeral keys of the sender and its long-term shared secret to create the HPE context, and it would use open function to decrypt the ciphertext, which will be either the plain text or the content encryption key. Yeah, this is just some examples to illustrate the new parameters and how it's being used. So the algorithm is direct in case of HPKey direct encryption mode. We have a fully specified HPKey cipher suit mentioned, and then we have the encapsulated key being sent to the receiver so that it can use it within the decrypt operation. And then the HP key encryption mode, where we have the protected header, which includes the encryption algorithm used for encrypting the payload. And then for each recipient, the algorithm and the encapsulated key that will be sent to the receiver. And I don't recollect any pending comments. We have addressed all the comments received so far, and it looks ready for working production calls. Sorry.
Any discussion on adoption? Not sure how to annotate that, but
Mike Jones, while I'm a listed author, I'll still say that for an individual draft, this has gotten a lot of attention on list from active contributors. So it seems to me like there's evidence that people want to do this work.
okay, so I don't hear anybody that's actively opposed to doing a call for adoption, so the chairs will issue one in short order. Okay, oops. Oh, the next thing is the cookbook without slides.
Yeah, sorry. If someone could take notes, this will be super brief. All right, I'm Ori Steele. I don't have any slides. The reason I don't have any slides is that you basically just saw the examples that are in the cookbook. So the cookbook is inspired by, I believe it's RFC 7520. I'm sure Philip can correct me in chat if he's still awake. And that RFC basically provides a number of examples for that are extremely helpful to implementers. You can go through them and you can see the structure of the messages that your implementation should support. There's some text around them that helps you kind of understand, like, what is this AAD property and like, how do I use it? And they align with, you know, the specification, but it's really just a grouping of examples. And the draft that I'm referring to, which I'm sure is available, hopefully, in the agenda, and you can click it, you can look at it, has some examples for HOSI and COSI HPKE. And so the reason I'm speaking to you here is that, as I think Tira mentioned, you know, like COSI HPKE is happening, HOSI HPKE might be happening soon, and developers probably would like a kind of consistent understanding of like these examples for direct encryption and key encryption that are like really, really simple, that can show you when you're using HOSI, it looks like this. When you're using COSI, it looks like this. Here's the key representations. They look similar. Here's examples for the two modes in HOSI and COSI. They look similar. And I think the main thing that I would like to sort of point out, and if you come to the COSI sessions, you'll see this in the COSI HPKE presentation. There's a difference right now in how COSI represents the ephemeral key and how HOSI represents it. So in the examples that you saw, you could see that EPK, ephemeral public key, is actually used to transport an encapsulated key. And that looks really familiar to HOSI developers, but you know, is that the right way to handle DHChems and HPKE? The COSI working group came to a different set of conclusions around that. That's the kind of alignment that doing this example document sort of helps us really see very quickly. And so, you know, please read the document. Happy to answer any questions you have on the list or in person if you have any questions now. Yeah, I've implemented HOSI HPKE and COSI HPKE, and the implementations that I've built, I use to generate the examples in the document that's that I'm talking about without slides.
Philip?
Hi, Ori. Hi, everyone again. I'm not asleep. Yes, it's 7520 for the Jose cookbook. As a library developer, I'd like to say that the immense value of a document like this is not the examples. Examples need to be included in the set specifications, not the example cookbook. The immense value comes from having verified vectors and maybe even a programmatic representation of them to use in your own development and testing.
I agree.
Mike?
Mike Jones, I'll just say that having Matthew Miller do the cookbook in parallel with developing the initial Jose specifications that became 7520 was super useful to make sure that people had those test vectors that Philippe is talking to and human readable versions of them so that people had stuff to test their code against. So that was great. So I like this kind of work.
Okay, Richard?
I was confused when you call this a cookbook. If you call it a test vector document, yeah, awesome.
Okay, anything else on this document?
No, and I didn't actually didn't even mean to get on the agenda. It just has the word Hosey in front of it. So when I published the draft, it showed up. So I'm not asking, for adoption, but I would love comments on it. And I think the next step for it is like to sort out these remaining differences between the Hosey working group and the Cozy working group. And once those are sorted out, maybe the document with additional changes and maybe some more machine readable processing capability, maybe then I would come back and ask for adoption in Hosey or Cozy. So just, that's what I'm thinking right now. But if you have different opinions, I'm happy to talk with you on the list or off the list. Thanks.
All right, thanks. Joe? Yep. Joe Salloway, are you in the room? Yeah, you're on the queue. Oh, okay. Brian?
I think it was Philip wanted to second the point that the cookbook shouldn't be a replacement for the kind of examples that you would see in the core document itself. And I get a little concerned that it would be used as the vector to sort out those issues. I feel like the document itself should be sufficiently.
Yes.
Yeah, so I completely agree with you. Part of the challenge here is you've got two working groups both doing HPKE. So I can't, in my Hosey working group, tell the Cozy working group what to do. I mean, I could, but I don't think that would go over well. So I wrote a separate document that kind of compares both of their approaches. So you can see each of them. And it's not, we're currently not on track to be adopted in anywhere. It's just, for me to kind of make the argument clearly in one place. Hey, did you notice that they use a header parameter and we use the EPK, our existing header parameter, to move the encapsulated key? That's like the only remaining difference. Can we get rid of that remaining difference? It's been to support those kinds of conversations on the list, not to provide the examples that you should see in the specifications, just to be crystal clear.
That makes sense.
And it could become something more if we want to make it more machine readable or make it easier for developers. But its original purpose was just to coordinate between Hosey and Cozy in a visual format.
Thanks. That's a little bit different framing. That makes sense. Thank you.
Yeah, Mike Perak here, because I think 7520 is listed as like examples of Jose, et cetera. I think is the titling or something like that. But the cookbook terminology could be a bit confusing because you're thinking more of patterns. I do see as like someone who maintains multiple APIs that, go in and say, oh, I want this in CBOR or using Jose or, JSON or Jose, depending on what it is. It's very helpful to make these kinds of comparisons, and it's very helpful for my development teams for me to be able to point to something like this and say, see, this is why this is different, and then to be able to raise issues if we find things with specs under development. So it is a very helpful tool.
Go ahead, Mike.
So Mike Jones, I'm going to disagree slightly with my friend Brian. Always a good thing. What Matt Miller did for us in 7520 was create testable examples for every algorithm. 384 and 521 and different key lengths and all the key wrap modes and all the key encryption modes. And I was not about to put that amount of examples in the doc. The examples in the doc were there in my mind to help people understand what the heck we were talking about. He produced a developer resource, and while they're overlapping, they're different.
Just one comment on some of the complexity that still remains even within HPKE, the AAD scenarios that you can run into, and APU, APV, considerations that, potentially could end up being implemented differently in COSI and HOSI. Like those are the kinds of edge cases that seeing them addressed in both formats, would be super nice, or seeing them not addressed in both formats and consistently telling you don't do this would also be super nice.
Okay, thank you. Next is the HOSI COSI guidance. Oh, Yaron?
So I will really be brief. Next slide, please. Hannes presented the draft in Prague. There was some interest in the draft. Me and Philip, who never sleeps, Skokan, joined. We issued a call for adoption on the list. We got some positive feedback, but also some feedback saying this is quite thin. What is really the scope of this document? And it's a good question. We created a repo. We met several times. We have a few issues open for the draft, including rather extensive review by Carsten. Thank you, Carsten. And we do plan to update the draft shortly after Brisbane. And then once we have the scope clarified with these issues and with some ideas of the various participants, we will come back to the working group for adoption.
Okay, thank you. Oh, I should have asked, does anybody have any questions? I'm sorry. Nope. Okay, great. All right.
Hello, everyone. This draft was discussed. We got several comments on this as well. It's purely PQChems for Jose and Jose. Yeah, I mean, I don't want to spend more time on this, but existing traditional asymmetric algorithms will be broken with a cryptographically relevant quantum computer. There are several algorithms that are being standardized by NIST, and the top one is MLChem. That's already used by several other protocols. What this draft is, Chem is basically a very simple mechanism where you have three APIs, basically one for generating the keys, sending the public key to the server or any peer that you want to encrypt messages, and then the encap would be used to generate the shared secret and the ciphertext, and the ciphertext would be sent back, and decap would be used to generate this shared secret. So what we're trying to do here is a migration path, basically from traditional asymmetric crypto to hybrid schemes. Hybrid schemes would be done in Jose and Jose with the HPKE scheme. We have published a draft on how that can be extended, and then eventually there has to be a transition to PQC Chem. As we all may know, CNSA 2.0 standard requires PQ Chem to be used, and ML Chem has been around for 7 years. And I believe that once cryptographically relevant quantum computers arrive, we will have to deprecate the existing traditional one. But I see some discussions in other working groups that they want to transition directly from traditional to PQC chem. I'm not sure about that, but this is the path that I think would be the right way to transition with least risk involved. So what we are trying to do in this draft is just use the encap operation and then do a key derivation function. We are using kmac for the key derivation function. And similarly for the decap, where the same kmac would be used. The simple registration functions is the PQC algorithm followed by the KDF function, which is very similar to what ECDHES does. And then we add the key wrapping AED algorithm for key encryption as well. Yeah, and the two modes, direct encryption and key agreement with key wrapping, would be supported with that. And a couple of examples. We had to add a KEM cipher suit because we don't have anything within, unlike COSE working group, where there is the encapsulated key parameter there. Unfortunately, in Jose, we have the encapsulated key being sent in ephemeral public key. So the working group discussion was not to piggyback on that. So there was a discussion that we had to introduce a new parameter for carrying the ciphertext. And very similar operation even for the key wrapping, where the algorithm and KEM ciphertext will be mentioned in the recipient headers. And yeah, this looks pretty straightforward, but we want to hear the working group consideration whether they think it's ready for adoption or not.
Ori?
Hey, co-author for the other HPKE stuff. Sorry for what I'm about to say. I feel like this is adding algorithms just for the sake of adding algorithms to HOSI. So cryptographic algorithms aren't Pokemon. We shouldn't try and catch them all. The HPKE algorithms give us the security baseline and the migration path to hybrid or pure PQ chems. But they also give us these additional HPKE security baselines, which I feel like are important. And the details around how to use these constructions in the existing HOSI envelopes, and potentially these same structures within the existing COSI envelopes, we're going to end up seeing potentially a lot of duplicate or equal strength, or maybe not perfectly equal strength duplicates in terms of fully specified encryption suites. And I don't feel that all of those encryption suites are necessarily providing enough value to see all of them. So in the words of Harold from Alt Dispatch, like there should be only one. Let's see, which one folks want, and let's just do that one. Let's not add a whole bunch of new algorithms that are essentially doing very similar things if we can avoid it. So that's my comment. But
yeah, thanks, Ori. I mean, I get your comment, right? Especially for hybrid scheme, we have to go with HPKE, right? It's pretty much can take both the ones. But whether HPKE is required when we go to PQ chem, right? That I'm not sure why we have to leverage HPKE, right? Richard Barnes is here, he's the author of HPKE, so I'm pretty sure we can listen to his.
John Price Mattsson, Ericsson, talking as myself, chair hat off. I think IETF should adopt all the algorithms standardized by NIST, just take them, all variants, stop arguing. I plan to use hybrid, but I would like to see separate algorithms. Seems to be at least unclear whether you can use hybrid and be compatible with CNSA 2.0. Then I think it would be bad to have individual algorithms and HPKE overlap. More so I think that should be avoided. I'm a bit confused about how to divide these PQC drafts between COSI and HOSI, but that's another question. You made the algorithms recommended no. I think the right term would be optional. No doesn't exist in HOSI.
Right.
I'm Richard Barnes. Yeah, I actually enqueued to ask why there was KMAC in your cipher suite identifiers, which I'm guessing is to align between the size of the secret that Kim produces and the size and the key you need.
Oh,
for-
the reason why we used KMAC was that we have Jose context and Cose context, so we wanted to add that as one of the salts into the
Gotcha.
final derivation key. So that was the reason. And then we also wanted the size to be the size that we would want to encrypt the payload. So KMAC gives that. So that was one of the reasons for picking KMAC. And if my memory serves right, NIST recommends to use KMAC instead of going towards using Shake, but KMAC internally uses C-Shake anyway. So I thought it gives all the flexibility that we wanted looking for.
Cool. Yeah, no, that actually reinforces the point I ultimately came up to make, which is that Ori seems to be right. I think this working group does best when it invents the least cryptographically. When we are taking things that have broadly the shape we need for Jose and plugging them pretty directly into the Jose framing. And so I think the work that's been done on the HPKE drafts has done that alignment. HPKE, you know, they've kind of done the alignment, and so like we shouldn't do the extra work of redoing all that work here. So I think Ori was right on in terms of keeping the focus on HPKE, because that will cover both the hybrid and the CNSA2 pure PQ cases.
Mike Parak here. I'm going to strongly concur with Richard and with Ori there. There are bits of this that feel like defining some new crypto, and it's hard enough keeping track just on the signature side with PQUIP and all the various groups between what we're doing at LAMPS, what we're doing here, right, and getting all that stuff in line. Right now, HPKE, for better or worse, is what is seeing traction and solves both use cases. So I think until we kind of finish hashing some of that stuff out, that feels like a good starting place. Do you have any comments regarding some of the discussion around MLChem and Kyber and some of the related things from CFRG this morning? Were you at that session?
No, I was in the whimsy session.
I would definitely go review some of that materials and maybe do some brain picking. There are areas that might be adjusting here, right? So I would just be aware, and the reason, for instance, when we even suggested moving forward with like Cose and Jose's side of just the pure signature side was when we knew that the parameter sets were close enough to something we could build and test against, and still knowing those things were going to change. There are bits of this that just really concern me, and if we can do it in one consistent way, let's do it in one consistent way, even if this exists. And because I'm not sure how much of this we would do in Jose necessarily with MLChem if we had to, right?
Yeah, that's a very good comment. I mean, in fact, I was talking to the authors of the LAMPS working group when they were using MLChem and made sure that our mechanism is similar to that. But I was asking them if they could place it in a separate document, right? But I don't see such a document available yet. So yeah, hopefully that happens.
Okay, I'm not hearing any sort of momentum to adopt this draft, so I think
we're good to wait for some more
good
time.
to wait. Okay, great. Thank you. All right, Paul.
Thanks. Hey, I'm Paul. I'm presenting on ECDH Mac-based signatures, and I see that I have a copy-paste error underneath my headline. So just skip to the next, go to the next slide, please. What's the idea behind this? I'm proposing to add a new Jose algorithm and a little bit of background story because it might be controversial. In Germany, we have a national ID card that has a functionality for identification, pseudonymous authentication called extended access control, and it enables to share this data in the identification part by not using assigned data, and instead it's using ECDH key agreement, opening up a symmetric channel and then sending the data in plain text. And doing some other privacy-oriented decisions there. And we are currently in the design phase for IDAS2 based protocols, and especially I'm in the German architecture team for the German IDAS wallet. And we're having a lot of discussions with BSI, which designed these protocols for the German national ID card back in 2010. And so BSI was proposing to use something similar in the verified credential ecosystem or IDAS 2.0 to achieve certain privacy targets. Next slide, please. Yeah, so motivation is from the architecture document in the German IDAS wallet. And besides many other things, we came to analyzing the comparison between issue-assigned credentials, which is, I would say, what the majority or almost everyone in the VC space is doing, versus what we believe could be an option, and we call it authenticated channel credentials. Next slide, please. And I think so BSI is one of the main driver behind this, and what they often push forward as an argument is repudiation or probable deniability. I've added a definition of repudiation, or our definition of repudiation here. I think it's no surprise to anyone in this audience. We mainly want to deny afterwards to a third party that a transaction actually happened. And with ECDH plus MAC, that's very easy, because we can always argue that the other party that we've shared this information with, or the unsigned data, then or the MAC data in this case, could have made up this MAC as well, because we did a key agreement with them beforehand, so they have the key for the MAC that we're using afterwards as well. And also interesting, maybe we differentiate between two repudiations, especially in the VC context. And then one of this is the authenticity of the data. That would be like the issue assigned part in the normal VC space. And then also the deniability of the user's presentation of this, thinking in SD JOT terms. The first one is the SD JOT, and the second one is the KB JOT. Next slide, please. You can argue a lot on repudiation, and this is probably also what I expect the discussion of this draft to be, if this actually makes sense at all or not. The point of BSI is that they think data breaches are just a matter of time, and relying parties will be lazy, and they will store the whole presentation of verified credentials that you will get. And if IDAS2 picks up a lot, then we'll have a lot of issue assigned data floating around, and they don't necessarily want this for the PIDs or the like national ID card equivalent, if some people are not familiar with the term. And they will be level of assurance high identification data issued by the governments, and they don't want that this data, or like if there is a data leak at the relying party, they don't want this data to be signed by government, because it would make this data even more valuable in the dark markets for sale. That's one of their main arguments. And they acknowledge some use cases where the third, where you want to show that you have received this data to a third party, but they say, well, in this cases, you should not use PIDs or EAAs or verifiable credentials, but you should use qualified electronic signatures. Next slide. So what's the proposal? It's a new algorithm that's doing an ECDH key agreement first, deriving a key, and then using a MAC on top of this, and picking up the ideas of fully specified algorithms. I see there are 3 parameters that go into this. First one is the elliptic curve that we're working on, and we have a key derivation algorithm and a MAC algorithm. Also, this is how an algorithm could look like using the NIST P256 curve. The concat key derivation function that's also being used in ECDH ES, and then HMAC 256. Next slide, please.
Michael, you're in the queue. Did you want to ask now? Do you want to ask questions at the end, or Paul, do you want to finish, or do you?
Oh, there's one more question, but you can ask straight away if it's important to you.
Okay, go ahead.
So I just wanted, so Michael B, UK NCIC, I just wanted to ask is, because this isn't a construction I'm familiar with, is this something that CFRG have specified, approved, discussed, analyzed, or is it something new?
This hasn't been presented to CFRG. No. This is, I would say, a very basic combination of things that is also being used in other spaces like ISO-MDoc, for example, or in the German national ID card in very similar.
Yeah, this overall pattern, I think, is not really well described, encapsulated, and analyzed as a standalone thing, but this pattern of using ECDH plus a MAC is pretty commonly regarded as a designated verifier signature. In particular, the way you have personally have probably used it is in the Signal protocol, because that's the only authentication you ever get in Signal, is that you did an ECDH with someone and got AED correct encryptions with keys resulting. So, you know, it's a widely used pattern. I don't know if it's, you know, pulled out and analyzed as a discrete thing all that much.
Yeah,
You're up, John.
John Matson, talking as myself. Think I agree with Richard. Like, this is a very simple and well-known contract. I don't think we need to ask CFRG about everything. Yeah.
All right, Paul, you ready for the next slide?
Yeah. Hold on. I've wrote down like a very simple algorithm that's also present in the individual draft right now. Well, it's, yeah, what I said. We perform an ECDH key agreement, possibly verifying that the key from what I call the generating party is signed, for example, by an X5C header. Also, the thing is a little bit, so it behaves like a signature. So I mentioned the 2 parties as a generating party and the verification party, because people might argue that it is not a signature scheme, but it behaves like a signature scheme. So afterwards, we derive a symmetric key by the key derivation algorithm from the shared secret, and then we generate a MAC on the symmetric, based on the symmetric secret. And then in the verification, it is basically the same, and the verifier compares the generated MAC with the one that he got over the line. And last slide is an example. So a new algorithm in a JOT, so it's a JSON Web Token example, sorry. We have the algorithm and the header. Then we have the KID, which is the key ID pointing to the ephemeral key that the verifying party sent us before. And we have the ephemeral public key, EPK, which is the ephemeral key, JSON web key used by the generating party, and optionally the X5C header that signs this thing. Then we have some claims, and in the end, we have the base 64 encoded MEC. This is what it could look like. And yeah, all these pieces more or less exist in the OSI spec. We have ECDH, ES, and we have all these MECs. So it's kind of plugging existing things together, in my opinion. And my actual last slide is a summary. So it's an easy way to offer reputable signatures with established crypto. And it brings a similar mechanism that's in a kind of similar fashion that we know from MDOC to the JOT space. We have two different, we currently see two different use cases how we would want to use this. So this could be used for on-demand, on-the-fly generation and presentation of verifiable credentials. So this is one architecture how you could use that. So you could argue it's similar to an IDP flow where the wallet sits in the middle and the relying party is not known to the issuer. And also you could do that without an issue, and maybe you have some trusted logic secure element thing that is acting as the generating party. And that may do reputable BC presentations to a relying party. The main disadvantage that comes with this flow is that the relying party usually has to provide an ephemeral public key, especially with the correct curve ahead of presentation. So this brings some challenges to the protocol design. And that's it.
All right, Richard.
Hey, Richard Burns again. Yeah, I think it would be useful just in terms of terminology here. I think what we really have here is you've created a designated verifier signature scheme. That, I think just framing in that term will make it easier to match against the literature. I have, in terms of doing this in Jose, some folks who've been doing some other stuff with me will know that I'm uncomfortable mixing things with different security properties in one syntax. Right, so mixing, standard JWS that has standard signature semantics with JWS that has designated verifier semantics makes me a little worried. I don't think anything terrible is likely to happen if they get confused. We're not going to have like alg-none issues, but we should think carefully about that and do more analysis than me just standing in the microphone. Last comment is, I don't want to be the guy that's like, always use HPKE, but it occurs to me that the HPKE with DHChem at least has an auth PKE mode or an authchem mode where you can plug in two keys, one of which would be the signer's key and one of which would be the verifier's key in this case. So it may be useful just to reuse that. You could reuse all the good stuff that's been done in terms of defining the algorithms for that. Just add an auth at the end or something like that. And off you go. And if anyone invents a PQ chem that has auth chem interface, you'd be able to use that too. So anyway, just some suggestions there. Thanks for doing the work.
Ori.
Yeah, I queued to say basically everything Richard said. Just one comment is like the auth mode stuff. It's not entirely clear how easy it is to do auth mode, like a pure PQ chem with auth mode. And, in the interim, you might consider, pure PQ chem as a replacement for this ECDH component that you're talking about here, or a hybrid chem as a replacement for those components. But then again, to say the same thing that Richard said, like maybe just use HPKE, because otherwise we're going to be having the same chem conversation we just had again for this.
Did you? Oh, you're not. Okay. So next steps for this, further discussion and comment on the list. Doesn't sound, I'm not hearing a groundswell to immediately adopt it.
Sorry,
You-
can I?
Go ahead.
I don't want my comments to be interpreted as like overly critical. It sounds like this approach is sort of either being rolled out, regardless of whether it has HPKE or not. I agree with Richard's comments about the worry, the concerns around just having a JWT syntax show up that has these specific security properties. But overall, I'm really supportive of the fact the draft was written. It summarizes these designated verifier signatures, is whatever the right language is around that. I think it's been a helpful document. Love to see it continue to evolve to reflect whatever governments are actually doing.
John Bradley. Paul, I know that you're not doing this in a vacuum. Are there particular time deadlines that you're facing that we should know about for considering adoption, and or are you willing to consider the HPKE alternative?
So I'm not too familiar with the HPKE stuff, so I will research these alternatives. But yeah, as you are in the IDAS projects involved yourself, you can imagine that a time pressure is omnipresent. The main purpose was to get the ideas out. So also saying that these ideas are very early and may not reflect the mainstream of where people are going with verified credentials. So it's kind of, it looks odd to many people, I would say. But I think BSI is also an important voice for all these government-related projects, and they have an opinion that should be not maybe ignored, and that's something that's very important to them. So yeah, I don't know how this will evolve, but time pressure is mediocre, I would say.
Okay. Brian?
We've discussed this a little bit, but I wanted to say it in front of here. In terms of time pressure, I'm wondering if, or how, I don't know how to say it. There's the possibility too that the normal existing HMAC algorithms for JWS could be used whilst building the key exchange and KDF on the higher level protocol for that, which still feels like it might be a faster path to actually getting something to work. I think, or I don't know, that's been my perception. I've looked at some of this stuff and looking at the actual draft itself, I've tried to express this too. I get really confused, and I'm not sure it's just me. I think maybe the draft is very confused about whose key is ephemeral and whose key would be static, and what you're actually proving to whom and how you convey those things, all layered on top of Jose, where there's sort of an implicit assumption in the things now that there's sort of like one key operating on whatever it is we're doing, particularly in JWS, and some of the comparisons to ECDH and JWE are a little, at least for me, confusing because the flow of things is basically reversed, and the keys, who owns what keys and what you're proving in reverse. So I don't know if that's very constructive, but instead of going all the way to HBK, maybe none of this is actually needed, and the key exchange could be built into the whatever's using it.
All right.
That was
Thanks.
incoherent, but that's what I got.
Michael, can you be quick?
Yeah, I'll be nice and quick. I'm like Ori. I appreciate you doing the work. I would like to see some like terminology alignment with the rest of the field and maybe some clarity in the draft just so I could understand better before I was like, yes, let's adopt this as a work item. I would also like to make sure that the work item does account for some of the actual problems with store now, decrypt later that are pretty well understood and discussed because I'm not seeing that covered in the draft as is.
All right, thank you. And for our last agenda item, you are muted. Can you unmute? There you go.
Hello, everyone.
So go ahead. We can hear you.
Okay. Hello, everyone. I'm Zhang Jinling, an IT development engineer representing China Unicap. It's my first time attending an IETF meeting, so I'm really excited to be here and looking forward to learning from you all. Let's begin look at slide, which outlines the main objectives of our discussion. The title of our document is JSON Fine-Grained Access. Firstly, let me introduce the significance. Next slide, please. Traditional access control methods, such as role-based access control and attribute-based access control, although protecting data security to some extent, gradually show their limitation when dealing with complex and dynamic data access requirements. To address this issue, this paper proposes a JSON-based fine-grained access control method that can be applied to various scenarios, such as web service, cloud computing, and Internet of Things. Next slide, please. In this slide, I would like to briefly introduce the data structure we have established. JSON-based fine-grained access control data format is standardized format used to initiate access requests to access control system. In cases of JSON objects that contain the requested access resource and their fine-grained access conditions. Request ID is identifier of request. The subject identifier representing the access subject. Operation indicates the action identifier of the request body, such as read, write, update, and so on. Resource indicates the identifier of access resource. Condition refers to the fine-grained attributes of the access subject. Next slide, please. The next slide will break down the proposed implementation process into 7 main steps. The first one is the client send authentication information to the server and receive a GWT token. The request sent by the client includes a token, and the payload of token contains information about the accessing subject, access resource, and attributes. Resource servers set fine-grained access control policies for different resources, which are represented by an access control tree. The server refines the validity of token, passes the payload information, and extracts the access information and the attribute information. Next slide. Based on the extracted information and the predefined access control policy, it is determined whether there is a corresponding policy. If there is, the access conditions are checked to see if they are met. If the conditions are met, access is granted. Otherwise, the access is denied. The resource service encrypts the requested source using the ciphertext policy attribute-based encryption algorithm. The encryption process incorporates the access control policy corresponding to the accessed resource. The encrypted ciphertext is then sent back to the client. At last, the client generates a decryption private key based on a set of attributes included in the request using the algorithm. After receiving the encrypted ciphertext, the client verifies that the attributes in the attribute set can satisfy the access control policy. Only if the attributes meet the policy can the client decrypt and access the resource. The above is all the content of the draft. Thank you for listening. Do you have any suggestions or comments about our draft?
Any questions or comments?
Hi, John Bradley is an individual. Thanks for doing this work and sharing it with us. My observation is that this probably isn't Jose work. So Jason, this fits more closely to JSON Web Tokens, which is actually in the OAuth working group. So I suspect that this is probably closer to something that the OAuth working group would pick up, or potentially some other working group. Because this is at the, yes, it happens to be signed by JSON Web Signatures, but is, as you said, part of a JSON Web Token and a refinement of that token. So yeah, unless this is directly impacting the crypto envelope of that, probably would be better off someplace else. So maybe we can help you find some other place that might be better able to deal with this work.
Okay, Michael.
Yeah, I think I just put something in the comments very similar to what John said as an individual, but this feels very much like an OAuth or an app kind of useful type function. Like, hey, here's this protocol. I need to go request these very specific pieces. Very great utility. It's a very neat concept. I could totally see the use, but I think it's probably better suited at something that's more protocol oriented.
Okay, so perhaps the chairs can work with you all to get it in front of the OAuth working group. Is that okay?
Okay.
Okay, thank you for your presentation and your work. With that, that brings us to the end of our agenda with 2 minutes to spare. I wish I could say we planned it that way, but if there's no, is there any other last minute business? Last time we asked if we wanted to do interims and you all were content with working in the GitHub repos and just meeting at the next IETF. I assume that is we're going to continue with that mode of operation. All right, seeing nobody in the queue, everybody have a good day.
They have a job they uploaded yesterday.